Hi! So in this mini lecture, we are going to learn where in a substrate a double bond gets formed during an E2 reaction. So, in many substrates, a base can remove different protons. Right? And by removing different protons, different types of protons, it will lead to different constitutional isomers of an alkene. And now we will learn to judge which protons react preferentially with a base. And we'll see that generally one constitutional isomer forms in preference over the others. And so if that happens, we call such a reaction where you get two potential products but one forms preferentially, we call such a reaction a regioselective reaction. So E2 reactions are often regioselective. So for instance, if we react 2-bromo 2-methylbutane with ethoxide anion, we get an E2 elimination. Right? And the main product we obtain with the ethoxide base is actually 2-methyl-2-butene. Why? Because this is an alkene which has three substituents, right? 3 alkyl substituents, so it's a tri-substituted alkene. It's the most stable alkene we can form. However, the ethoxide base can also abstract a green proton from position 1, right, of the butane backbone. And now if this happens, we obtain 2-methyl-1-butene. So again, in the case of ethoxide, the red product, which is also called the Zaitsev product, forms in 71% yield. Again, that's because the Zaitsev product is the more stable alkene, and ethoxide is not very sterically hindered, so it can actually reach both protons and just forms the more stable product. But next, I want to show you how we can use the base and carefully choose the base to get preferentially the Hoffman product, the other product instead. We can achieve this by using a bulky, sterically hindered base. Why? Because if the base becomes very bulky, it can't reach the internal protons, and so it will make the less substituted alkene. On the other hand, again, an unhindered base like ethoxide will just favor the formation of the Zaitsev alkene, the more stable alkene. Let's see this effect in action for the reaction of 2-bromo 2-methylbutane with different bases. We can form the Zaitsev product or, of course, the Hoffman product, and we're going to now list different bases and the percentage of the Zaitsev and Hoffman products for these different bases. So as we've already seen with ethoxide, we get 71% Zaitsev product, 29% Hoffman product. But now how can we make ethoxide more sterically hindered? One way to achieve this goal is to attach 2 additional methyl groups to the carbon attached to the oxygen. And now the base is much bigger, right? And it's called tertiary butoxide, a very common sterically hindered base. And it's so sterically hindered that it just can't easily reach the protons which are attached to the 3 position of the alkyl halide. And well, therefore, we mostly obtain the Hoffman product with tertiary butoxide. This effect is even more dramatic when we now make the base even bulkier, right? And in the case of attaching 3 ethyl groups to the carbon attached to the oxygen, we now get almost exclusively the Hoffman product in 92% yield. So this is how you can use the base to control the regioselectivity of E2 reactions.